So now that we have an idea on how we are going to be setting up our experiment and how many plates we're going to need, it's time to figure out our consumable requirements. So the consumables will include obviously, your plastics like your plates and your tips and tubes and whatever serological pipettes you need to use, all those things. It's also going to include your media, wash buffer, trypsin, those type of requirements. So to set up enough cells, to have enough cells for 6 well plates, each 100 millimeter square plate is going to typically give you enough to plate 1 to 2 well plates, depending on how confluent you want your cells. Now, if my goal is to maximize the amount of protein I can get, I want to plate my cells to about 40 to 60% confluent. I don't want them to get overly confluent because the drug may affect them differently at that time if they are not in their logarithmic phase of growth. But typically my goal, and I have some early time points, so that's not a time when cells are going to be dying or getting too much effect. You're just looking at molecular effect. So you want to have enough cells to be able to extract a lot of protein from them. You don't want to start off at 10%, right? So if I'm going to be plating them at about 50 to 60% confluence, then one plate of cells can give me 2 plates of 6 well plates. So that means that I need cells from 300 millimeter square plates, right, for the 6 well plate, right, to get my 1, 2, 3, 4, 5, 6, there we go. Then each plate, each well in here takes 2.5 ml of media. You can go up to 3 ml. You don't want to overfill them. Again, that's one way to make sure you have enough drug or conserve the amount of drug you need. 2 to 3 ml is recommended. So 2.5 ml per plate, per well. In a 6 well plate, that means that you're going to use about 12 to 15 ml of media, right? So you need approximately 12 to 15 ml media per plate. When you plate the cells, you're going to plate them with full serum, whatever that full serum situation is in your lab, whether it's 5 or 10%. However, when you add the drugs, you want to reduce the serum to about 2.5% to enhance the effect of your drug and to be able to see it better. So if you are using 15 ml, let's go with the higher number. And, so it's going to be about 72 to approximately, 96 ml media total. Before treatment, before switching to treatment media, you are going to wash the cells a couple of times with PBS, again with 2 to 3 ml of PBS per wash. If you wash them a couple of times, so you'll need approximately 200 ml of PBS for washing. You are also going to need it to wash the cells before collection of extracts. So you're going to, again, but right before you collect the cells, you're going to remove the media, you're going to wash them again, and then you're going to extract your protein. So you're going to need about similar amount for wash before extraction. And so those are like just the basic things that you will need for your experiment to work. Similarly, now you also want to think about how many tubes you're going to need to collect your samples. So for each sample, at each time point, you're going to have a single tube. You could divide that up into 2 tubes if you want to conserve one and keep it in the freezer for future or backup, and then have one set that you are using. I typically extract from a small well with anywhere from 50 to 100 microliter of extraction buffer. Let's say that we are going to extract with 100 microliter extraction buffer per well. And then I am going to split it into 2 tubes, one as backup and one to use. So you are going to need 12 tubes per time point, and you're going to need, that means 72 tubes total. Another good thing to do to save you time during extraction is to actually pre-label all your tubes, organize them into a container, and freeze them. Put them in the freezer. That way, when you take them out for extraction, they're already cold. You can quickly go through your samples, extract your proteins, and return them back to the freezer, preserving the health of your protein extracts and making sure they don't degrade.